Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. How's everybody doing today?
Good. How are you doing?
Good, good. Yeah, how's the midterm?
Harder than the last one.
Okay.
More challenging for sure.
Okay, yeah. This the second half, I think, is it sneaks up on people a little bit because it's definitely a lot of calculations. So I haven't started grading those yet. So I was planning on starting them tomorrow because tomorrow's a day off. So I'm basically gonna have all day to grade. So hopefully by Thursday I should have the grades ready for you. Okay. And so besides that, today we're going to continue on with our discussion of ethics. And so we're going to go into probably the biggest topic of engineering ethics today, which is risk and safety. And so a lot of the engineering ethics case studies that you guys will be looking at, they have something to do with risk and safety. Okay? So the question is, do we have classes tomorrow? So we don't have class tomorrow because we only meet on Tuesday, Thursday, but your other classes that normally we meet on Wednesday, they shouldn't have classes tomorrow because it's Veterans Day, so it's a holiday. But you should definitely take that up with your other professors and see what their plans are. But technically the campus is closed, so there shouldn't be any classes at all. But but maybe your other faculty, they might need to be reminded because I often forget sometimes when some of the holidays are too. But yeah, technically there shouldn't be any class tomorrow. Yeah. Okay. So before we get started today, I do want to talk about the project a little bit. So I uploaded a bunch of files to Canvas that I want to go over. And I also have the spreadsheet open for the groups, and it looks like everyone's kind of filled into a group. But it does look like there's one group that has a slot. So if you haven't joined a group yet, definitely send me an email because you guys need to really start working on that sometime soon. At least before the Thanksgiving break, you guys should know who's in your group. Okay. All right. Question. So do we have a fall break? I've been hearing yes, and I'm assuming we have a fall break. I'm hoping we get a fall break because that's the I'm right now I'm under the impression that we have the entire week of Thanksgiving off. So that's not next week, but the week after that, we should have the entire week off. But that's what I'm planning to do. So that entire week, I'm not going to have any lectures or anything. I'll have office hours during Thanksgiving week. Probably not on Thanksgiving Day because I'll be with my family, but on Monday and Tuesday I'll have my office hours. But besides that, there shouldn't be any lectures. But again, I would check in with your other professors and see what their plans are. So with the virtual instruction, they might plan to pre-record something during that time if they yeah. So it depends on the depends on the professors. They might try to pre-record something, but I don't plan on doing anything on Thanksgiving break because that's I feel like that's the time everyone should be spending with their families reasonably, safely. We're still under COVID restrictions right now, so no large gatherings. But you guys, I think we all kind of need that break for that Thanksgiving break. Yeah, that is true. Every day can be a break day. Okay. So make sure that you're in a group. Make sure everyone in your group knows that you're in the group. So make sure you guys are all on the same page because there is something that's due today for the project. And that thing that's due today is the agreement of shared responsibilities. Okay. So let me go ahead and share my computer screen. Okay. And so what I have open right now, this is the project specs. And so, if we look under the section for deliverables, you should see that there's something due today, and that's the agreement of shared responsibilities. Okay. So now that you have your groups, what I want you guys to do at this point is to kind of look at each of the different, aspects of this project and kind of divide the work up kind of as evenly as you can. Okay? Because with the group project like this, especially with groups as large as we have, I want to make sure that everyone's doing their fair share of the work. So the point of this document right here is to not for me to go back and check, see like who's doing what and for that, but I want you guys to have kind of a document that you all kind of agree to from the beginning that you guys can use to kind of help hold each other accountable for the project. Okay. Because I've definitely been in groups where we didn't really define our roles and we didn't define what we want to do at the beginning, and what ends up happening is that certain people in the group kind of do a disproportionate amount of work compared to other people. So I don't want you guys to have that experience. So that's why I make you guys write this agreement right here, just so you can say. So, the document doesn't have to be anything formal or anything like that. I'm not going to read them that carefully. But basically, one way that you can format it is, if you look at all the different sections for the project requirements, you can just list out all your names and said, like person 1 is going to do these sections, person 2 is going to do these sections, person 3 is going to do, and so on and so forth. And then at the end of the document, everyone should sign it just so that everyone kind of knows and is aware of, what everyone's going to do. Okay? Because some of these sections depend on the other ones. So, if you have that kind of dependency, you want to make sure that you do your part so that other people can do theirs as well. Okay? And so that's all this is. So it's nothing major. So if you guys can fill that out, if you can send it to me before the end of today, just have one person in your group email it to me. It can be a Word document, a PDF, whatever is the most convenient for you. Then that will be good. Okay. Okay. And so the other thing I want to discuss today is all the other files that I uploaded onto Canvas. Okay. And so if you go to the Files tab on our Canvas site, you'll see all the different folders that I've created. And if you click the folder project here, you should see that this folder is a lot more filled than it was before. So previously, the only thing I had was just the project specs. But I've also uploaded a rubric for the final project, so you can kind of get an idea of how I'm going to grade each section. I've also included a template for your final report. So this is a Word document that you can use just to kind of fill in all the sections. That's mostly just to make sure that you have all the sections that are there. So you can actually use the font and the spacing for this template if you want. But what I'm more concerned about is just to make sure that you have all the sections that are required, and they're in the correct order, so that when I'm grading it, it's a little bit easier. But you can change the font, you can change the spacing, if you want. I just want to make sure that all the sections are there and they're they're in the right order. Okay? And so I have the same things for your presentation too. So I've uploaded the rubric. So this is how I'm going to grade you guys for the final presentation, and also the template for the final presentation slides. Okay. So those will be there for you to look at. And so, you guys also have the luxury of being the second time that I've run this project with. And so I also have some samples that you guys can look at too. So I have folders here for sample reports and also for sample presentations. So I've included what I thought was the 2 best reports and 2 best presentations from last year. And so you can look at those and to see, what level of detail that they went into, how they formatted their report, how they, did the language and everything like that, how they formatted the figures. So, that'll be available for you guys to look at as well. Okay. And so, when you get the chance, definitely check out this folder, because there's a lot of good stuff in there that will help you out for the final project. Okay. Okay. And so the other thing that I want to talk about, not this one, let's see, is your homework 6. Okay. So homework 6 was just posted on Canvas, and what homework 6 is going to be, it's going to be the final homework. So there's going to be no more homework after this one. So after this, you guys are just going to be working on your final project. But what homework 6 is, what it is going to give you a chance to do is it's going to give you a chance to kind of practice writing this case study report. Okay. And so it's going to be an individual writing assignment, that kind of mimics the structure of your final report. So what you'll see here is I've included the rubric here for homework 6, and you'll see that there's a lot of sections that are part of your final report. But I've taken out a lot of them too, so you don't have. So it's not like you're writing, you're doing a full project by yourself, or you're just kind of writing, maybe like something that maybe is about a third of the length of your final report. Okay. And so just like we talked about before, so what you're going to do is you're going to choose one of the case studies here. So you can choose any of these 3. So I've given you 3 options. And then what you need to do is you need to write a report that includes the introduction, historical context, personnel context, what the key ethical issue was, any alternative actions, the conclusions, and of course, I'm going to grade you on the aesthetics too. Okay. And so remember, this is an individual assignment, so everyone's going to write their own report to this. But the point of this is so that you can kind of practice writing this, doing this style of writing and doing the research on this on your own, before you kind of do that for your final project. Okay? And it's going to be due on the Sunday before Thanksgiving week. Okay, so this is what I'm going to be doing over Thanksgiving, over the Thanksgiving holidays. I'm going to be reading your reports and giving you feedback. Okay, and so I'm going to try to give you guys as much feedback as I can on these reports, because I know you guys don't get you guys don't get that many opportunities to write reports like this, and so I want to make sure that you have at least one chance to practice and to get feedback from me before you do it for your final project, which is going to be worth a much bigger percentage of your grade. Okay. So this is going to be, so this is up on the on Canvas right now. So you guys can go ahead and check it out. And remember, you can choose any one of these studies here. So the first option here is the Space Shuttle Challenger. And so this was, one of the really famous aerospace, disasters right up there with the Columbia. And this was due to an O-ring failure. Right? The next option is the Citicorp building. And so the Citicorp building is a building in Manhattan, which had some design challenges, and actually, there was an ethical dilemma that was associated with that as well in terms of its design. Okay? And then finally, the third option here is Love Canal, which is actually an environmental option. Okay. Thanks. Thank you guys. You guys are very kind. Okay, so this is up there for you. So it's going to be due next Sunday. So you guys are going to have about almost 2 weeks to do this. Okay, and as always, I'm always available for any questions. So definitely reach out. And in terms of length, there's I don't have formal length requirements for this or the final project, but generally what I've seen from people in the past is that for this individual writing assignment, it ends up being about 6 to 8 pages. And then for the final report, I think it was at least 20, 25 pages, something like that. But it's not like you have to hit a certain page count. So don't fill your report with just fluff, because that's very easy to detect, and it's more obnoxious to read than anything. But just write as much as you need to. Okay. But those are just general, ballpark estimates for that. It sounds like a lot, but you'll see that once you start reading up on these case studies, then you'll see that there's going to be a lot to write about. Okay. Okay, I think that's everything that I want to talk about for the final report. Are there any questions before we get started with the lecture today? Okay, so let me rejoin on my iPad then. Okay, and so the topic today is going to be health, risk, and safety. Okay, and so this is probably when you think about engineering ethics, this is probably the thing that comes to mind most first of all, because a lot of the big engineering scandals and a lot of the big engineering mishaps and case studies, they have to do with public safety or something like that. Okay, and so we're going to spend this week talking about kind of defining what risk and safety really means, and what we as engineers can do to kind of ensure this. Okay. Okay. And so just to kind of start us off, just like we kind of mentioned that more than kind of any other professional responsibilities, engineers have a duty to protect the safety and well-being of the people that are affected by their projects. Okay. And it goes beyond just, of course, you should just in general, you shouldn't be doing anything that endangers other people. But also, we'll also talk about that, the vast majority of the people that use the things that you work on are not going to have the same kind of, technical background that you have here. Okay. And so, you guys are going to school, for a long time to learn about all the technical details of these things. So, but you have to realize that a lot of the people that use that will drive your cars, that will ride your airplanes and things like that, they're not going to have the same kind of training. So you have to, that responsibility is kind of on the engineer, because you guys are going to know what all the intricacies and what all the technical details that go into it. Okay. And so, because of that, because people don't have that same kind of technical knowledge, there's kind of an implicit trust that people have in your work. Okay. And as excuse me, and as the world gets kind of more and more, technologically advanced, this trust kind of grows by the day, right? It's it's kind of incredible to, at least for me, to see that. I grew up, when I was young, and I'm not that much older than you guys. I remember, having to go, if I wanted to connect to the internet, I had to kind of, dial in. I had dial-up modems. I still remember kind of the tone that it would make, and I would connect to a AOL, and run that. And going from that, and in just a matter of just like 15, 20 years, we're in the stage where everyone has like instant connection to the internet at the palm of their fingertips. So it's really incredible, how far we've come. And and you can see, you can predict, in the next 10, 15, 20 years, we're going to be even more. Okay. And as these devices and things get more and more complex, there's implicitly going to be more trust that are placed into the engineers. Okay. Yeah, you get a phone call and your internet stopped working. Okay? And so, as we go about our daily lives, there's actually, a lot of trust that you may not, notice. Okay. And so some examples for this are, say, like if you get into your car, right? And so if you get into your car, you trust that, your engines and your brakes are going to work, to get you properly from point A to point B. Okay? Okay. It's not something that you really think about unless your car is kind of a piece of junk. Then that's something you think about all the time. But if you have a reasonably good car, that's not something you think about that you have to do. Okay. Okay. And so another thing that you might trust would be the elevators. Okay. Which is really ironic, because if you guys were around the CS building last year, you know that we only had one working elevator for like most of the year. Okay. Right. And so we trust that if we get into an elevator, that elevator is not going to fall from the 5th floor and hurt us all inside, right? We just kind of trust that it's going to work as it is. Okay. And even something simple like maybe the thermostat in your room. Okay. Okay. So there's an implicit trust that if you go to adjust the thermostat, it's not going to explode in your face and and put hot plastic or hot metal into your eyeballs. Okay. And so there's a lot of things, and I think you guys have been around engineering enough now to know that a lot of things can happen to engineering products. And just by using all these, all this technology every day, we kind of trust that, that they're going to work, the way that they're intended to do. Okay. So in other words, the public, and even us, we have a lot of trust in the work that engineers do. Okay. And it's your first professional responsibility to kind of uphold that trust and to put safety first. Okay. And so, if you look at, last time I think we talked about some professional engineering codes. I think we talked about the IEEE code and the NSPE code. And so, if you read any engineering, code of ethics, safety is always going to be the first thing that's mentioned, and it's always going to be the most important thing that's mentioned. Okay. And so, ensuring this is going to be, the first thing that we always do. And so, I want to double back to, I think, something someone asked last week where, I think someone asked about, if we're going to go over like specific safety guidelines for specific fields. And, I really wish we did have time to do that, because I think that would be, a really cool thing and really important to see, what are some factors that, that people consider when they're designing airplanes or designing, theme park rides or cars. So unfortunately, we don't have enough time. So, when we talk about safety, we're going to be talking about things kind of in general. So it's going to be a little bit, frou-frou a little bit, just because it's, of course you should design things to be safe, but, hopefully, through this discussion and through, talking to some of your peers in this class, you gain some new insights and you kind of have a little bit more of a nuanced kind of understanding of safety. Okay. Okay. Any questions on this before I move on? Okay. All right. And so, before we kind of move on here, I do want to kind of qualify this a little bit, that it's impossible to make sure that something is 100% safe. Okay. And so even kind of the most mundane tasks with the most mundane, objects can be can succumb to some kind of misfortune. So if you're familiar with the series called Black Mirror, you kind of know what I'm talking about. So even something like just using the stylus, right? Probably the person that designed the stylus, probably did not anticipate someone would like stab their eye with it, kind of spontaneously like that. But it could happen, right? And so the question is, if you design the stylus and someone stabs their eye, with it, is that your responsibility? And so, of course, the answer is going to be no, right? And so, our job as engineers is not to prevent all bad things from happening. Okay. Okay. Because that's going to be impossible. But what we should do is that we should try to at least maximize the safety and reduce the risks as much as possible. Okay. I remember, when I was growing up, I had a friend, and he was was basically telling me how almost anything can be used as a weapon. So I think we were talking about like not being able to bring something into a theme park, and he's like, you can use anything as a weapon. You can use a pillowcase as a weapon. You can just choke someone with it. You can use a calculator as a weapon. You can choke somebody with it. And that's true, but most sane people wouldn't do that. So it's when you design something, don't and we'll talk about possible misuses of your product, but you don't have to come up with some things that are totally ridiculous out there like that. Yeah, yeah, you could do that too. You can kill someone with a pencil, but don't do that. So and if you go out there and design pencils, don't take that responsibility on yourself. Okay, so let's define some terms. Okay. Okay. The first, let's talk about risk. And so risk is just going to be simply just the possibility of danger or harm. Okay. And so the other thing is safety. Okay. And so safety is going to be defined as freedom from damage, injury, or risk. Okay. And so when you put it in terms of this, it sounds pretty simple, right? And so your engineering design should just minimize risk and maximize safety. Okay. But there's some nuance to this that's that can be that's important to talk about, which I'll probably start writing on the next page. Before I do that, are there any questions on this page here? Okay. All right. So let's talk about some nuance. Okay. And so the first, wrinkle that we'll talk about is voluntary versus involuntary risk. Okay. And so, what this means is that, the perceived safety of any kind of situation, or, how we perceive how safe a situation is it's higher if the risks are known and voluntarily accepted. Okay. Okay. So basically, if you know what you're getting yourself into, then it's perceived as less risky. Okay. And so, an example, that we kind of we touched on last time is, consider that you're buying a home near a chemical plant that emits some toxic waste. Okay. And so, if you kind of are made aware of all the health risks that are associated with, this toxic waste, then, the risk of and safety of purchasing a home near this chemical plant, they're going to be perceived as lower too, just because what they're going to be. Okay. But, if you say that, that there's going to be, a health risk of purchasing a home near a chemical plant, but you don't know exactly what those health risks are. So you can ask yourself, am I going to get cancer? Are my kids going to get cancer? Is it safe to play outside? Is it, can we go jogging around here? Am I going to have lung problems, stuff like that? If there's kind of the more questions that you have, the more uncertainty, then you're going to perceive it as, more and more risky. Okay. And so that's why, whenever you you sign up for an app or something like that, or you on your phone, they have that long list of, these are all the things that you have to agree upon. So the purpose of those things was so that, consumers can, have some ideas of the risk of, their identity might be stolen, stuff like that. But unfortunately, they're so long and so full of like legalese that that no one ever reads them. They just kind of skip to the bottom and say accept. But I think if you do take the time to actually read some of those, then, I think it would make you feel better than about using, those kinds of services. Okay. Okay. And so the second nuance that I want to talk about is short-term versus long-term consequences. Okay. And so generally, if consequences that only cause negative effects in the short term are perceived as less risky that something will cause permanent damage. Okay. And so, if you had the choice of, making kind of a small cut on your arm, for using something, but, that cut is going to be patched up, versus, you might get you might burn your arm and you'll have a scar that lasts for your entire life. The scar is going to be seen as more risky, or more a threat to your safety, because there's no undoing that scar. Okay? So as long as there's a possibility that something might be short term or might be temporary, kind of lowers the inherent risks that for certain things. Okay, and so the third wrinkle is going to be expected probability. Okay. And so the expected probability is that if the probability of an accident is low enough, then people will be willing to take on the risks, even if the consequences are dire. Okay. Okay. But on the flip side, if there's a high probability of an accident occurring, but even if the consequences are only minor, this is actually enough to push people away. Okay, so it's an interesting thing, because it's people I think for a lot of people the just having an accident or not is kind of just a black or white thing. And so if you think that there's a very low chance that something's going to happen, you might still be pushed to do some risky behavior, because you're like, it's not going to happen to me. But if there's a high probability of something occurring, but even if the consequences are only minor, say there's a high chance I might come out of this with a paper cut, then that's usually enough to push people away. It's a very kind of interesting psychology that's associated with that. Okay, are there any questions on this? Okay. Okay. And so the fourth wrinkle that we'll go over is reversible effects. Right. And so this is kind of similar to point number 2 that we made on short-term versus long-term consequences, and that a situation will seem less risky if the negative effects can be reversed. Okay. Right. And the last nuance that we'll go over is delayed versus immediate risk. Okay. Okay. And so, if you engage in an activity where the harm is going to be delayed for many years, that's going to seem less risky than something that with kind of an immediate consequence. So an example of this could be, say, you can go eat Chipotle, but a lot of times, when you eat Chipotle, you don't experience the consequences until you go to the bathroom later on. But that might seem less risky than eating a habanero pepper just raw, just like that. Because you eat a habanero pepper, you're going to experience the pain right away. Okay. And so, we talked about kind of risk and safety as kind of, these kind of black or white things, but there's a lot of kind of wrinkles to this, and it's which one of these that you consider and how you perceive risk, of course, is going to depend on the kind of work that you end up doing, right? And so if you end up working on automobiles, you're going to consider, different things, whether you versus if you work for like a medical, like a biotech company, right? And so if you work for a car company, you might try to minimize any kind of like immediate consequence, right? Because you want to ensure that your passengers are immediately safe, okay? But if you're working for like a biotech company, you might try to maximize kind of their long-term, health, right? And so you might sacrifice some discomfort immediately so that, they'll ultimately be healthy and safe later on. Okay? And so at this point, I want to take a brief minute just to, just to discuss. And so I'm going to break you guys up into breakout rooms. And what I want you guys to talk about is, I want you guys to, as a group, to kind of think of situations or think of products where you might consider, some of these effects, right? And so let's kind of narrow this down a little bit and say, I want you guys to come up with two products, okay? And so I want you to come up with one product where it's going to be more important to prioritize, short-term safety. Okay? Okay. And so it could be almost anything, as long as it's something that engineers ultimately work on. Okay. And I want you guys to come up with another product where it could be important to maximize long-term safety. Okay. Okay. Right. And so I want you guys to think about that a little bit. I'm going to fiddle around with this breakout room. So I'm going to break you guys up into groups of 4, and then you guys can discuss that. So I'll have you guys discuss for maybe about 10 minutes, and then we'll bring it back, and then we'll kind of discuss it as a group. Okay. Let's see. Breakout rooms. Oh, did I disable it? Oh, here it is. Okay. Let's see. So we have, okay, so I'm gonna break it up into 10 breakout rooms, okay? Hey guys, so it looks like you guys got the short end of the stick. So there's only 3 of you guys in here. So I'll join your guys' room here, okay?
Cool.
Okay. And so, what are you guys' thoughts on this? So, what do you think is one product that, it's important to prioritize short-term safety?
Short-term safety.
Maybe a spare tire.
Mm-hmm. Yeah.
That's a good one.
Oh, hang on. Someone's asking for help. Why don't you guys go ahead and continue this discussion? Okay. Hey guys,
Hey.
what's up?
Hi, Professor.
So I was wondering, we make up a product, or do we just find existing products?
Just find an existing product.
Okay.
Yeah, just find something that's out there where you think short-term safety would be more important, and one product that's out there that's where long-term safety would be.
Would you consider like a seatbelt a short-term safety?
Yeah, I mean, you can kind of interpret this, anything that you want. So a seatbelt, I think, would be a good option because you want to maximize kind of their short-term. If a crash happens, then you want to make sure that they're really safe in there, right? But a seatbelt also can cause some like long-term effects too. Like it's if you kind of crash on this, you might get whiplash or something like that.
Okay.
But in that situation, it's more important to make sure that your person doesn't.
They're alive.
Yeah, they're alive from that. So yeah, that's a great example.
All right. All right, got it. Thanks.
Cool.
All right.
Yeah, maybe safety pins. Airbags.
Yeah, I think airbags is a great one. You're talking about for long-term safety or short-term safety?
Short-term.
Short-term, because that would be kind of like more of an immediate safety concern rather than like, well, I guess it would count for long-term safety since the chemical for the explosion would have to be stable for a long time.
Mm-hmm. Yeah,
I guess a bit of both. Yeah.
Yeah, but I agree with that. It's short-term, airbags kind of have the same function as like seatbelts because you want to make sure that your person is going to be alive and after a crash. But there could be some long-term consequences too. Like I've seen a lot of reports where people get concussions from airbags that kind of inflate too quickly too. But I think most people would rather have a concussion than be dead. So long-term consequences will be there might be some associated with airbags, but in that case you want to prioritize kind of the short-term safety. So yeah, that's a great example of that. All right, what about long-term safety? You guys come up with anything for that?
Refrigerators.
You want to elaborate a bit more on that?
Oh, well, they just have to. Well, you don't want them to explode at all, and then they have to maintain a certain temperature for long periods of time. Yeah.
Yeah. No, I think that's a great option. Yeah, I think some people might consider maybe the short-term inconveniences for a refrigerator might be like it's it might make some noise or something like that which are more inconveniences than anything. But yeah, you're right. Like you design a refrigerator to make sure that everything in the refrigerator is going to be safe and fresh and cool for the long run, because that's going to affect the health more than anything else. So yeah, so that's a great option. I'm gonna go check in on some of the other breakout rooms, and then I'll come back. But those are some great ideas.
Cool.
Oh, that's a professor.
Hey guys, how's it going?
Good.
You guys come up with any products?
Martin
said one thing.
Okay, sure. What was the one thing?
Well, would something like you were talking about, so for a short term, something that prioritizes short term safety, would that be something like an ejector seat in an aircraft? Because it, keeps you from crashing into the ground, but you maybe break your back and legs when you get ejected. Would that be that's a short term?
Yeah, no, absolutely. I think that's a great example. Because short term, when you design an ejector seat, you want to make sure that the person gets out of the airplane in time, such that they're not going to be there for the crash. But there might be some long-term consequences, like maybe broken bones or maybe like whiplash or something like that. But I think most people would rather have a broken back than rather be dead. So that's a great example for that. Yeah.
Not Beast Carter.
We're just struggling to think of long term, I think. I'm trying to figure that one out.
Yeah.
Oh yeah. Maybe a better way to phrase that would be something that might have some short-term, maybe not safety concerns, but maybe short-term inconveniences, but long-term kind of health and safety benefits. That might be kind of a better way to phrase that.
I think.
Yeah, another group, what they came up with was a refrigerator, because it's short-term. The refrigerator might make some noise if it's kind of old or like that, or you know, short term, it's also going to cost a lot of money too. But it's but you know, long term, you know, its goal is to kind of keep your food kind of cool and fresh, so that you know you don't food poison yourself or anything like that. So you know that might be one good example to consider for that. Okay, so I'm going to check on some of the other groups and see how they're doing. But yeah, ejector seat's a great example. Hey guys, how's it going?
We're a little bit confused on the what's it called? Like, are we just pointing out short-term and long-term, like safety scissors and maybe like radiation or something from Kiva?
Yeah, no, I think those are great. So I just want you guys to kind of think of some examples of where the design of the product, short-term safety was probably prioritized more than any kind of long-term consequences, and another product where it was prioritized for long-term safety over maybe short-term inconveniences, something like that.
Okay.
Yeah, so maybe some examples that other people have come up with would be like seatbelts. And so seatbelts is something where you want to prevent any kind of short-term harm to the person. Like if your car gets into a crash, you want to make sure that your person's going to be okay. But some long-term consequences that could result could be like you might have broken neck or like whiplash or something like that. But those are preferable to being dead. So that's one thing where you design a seatbelt to make sure that someone's safe in the short term, right? And so long-term safety could be something like a refrigerator, right? Where you design something, or where you design a refrigerator where where maybe short term it might have some inconveniences, like it might make some noise, it might smell or something like that. But you want to prioritize so that you keep things running and you keep things cool for the long run, so you don't get any your food doesn't go bad and give people food poisoning. Right? And so I think you guys also mentioned like radiation poisoning as well, right? So that's another great example of you want to design containment devices to make sure that radiation doesn't leak out in the long run. Even if there are any short-term consequences, like someone might get their hand burned or something like that. But that's better than something leaking out and causing like an incident like that too. Yeah.
For sure.
All right, I'll probably check on one more group and then we'll probably bring it back after, just so we can have time, because I do want to do one more activity today.
Okay. Thank you,
Sounds
Professor.
good.
Yeah.
Thank you.
Hey guys, how's it going?
Hey,
Really good.
Professor.
Were you guys able to come up with products?
Yeah, for the short term, we discussed to have like a face mask.
Mhm.
And for the long term, we decided it's what we decided for the long term?
Cell phone cases.
Cell phone cases, yeah.
Okay. Yeah, great. I think those are really good examples. Yeah, cell phone cases especially, because it's you design that thing to make sure that your cell phone is going to be safe in the long run, even though you might have some short-term maybe inconveniences where your phone becomes too bulky to fit in your pocket or something like that. But
Yeah.
the point of that device is to make sure that your cell phone will be good for as long as you want to keep it. So yeah, so great examples. Okay, so I'm going to bring it back in about a minute. But yeah, sounds like you guys had a great discussion.
Yeah, we're chilling in here.
All right, I think it's time to bring. If you guys are chilling, it's time to bring it back. Welcome back, everybody. We'll wait a little bit for everyone to go into to join us again. Okay. So welcome back, everybody. So I wasn't able to join everyone's group, but the ones I think I joined about half of them. You guys had some really good discussions on that. So hopefully you guys could see that depending on the product, you might have to design for certain kind of safety over other ones. Okay. And so risk and safety, it's not kind of a black and white thing. you know, it's something that has, you know, a lot of nuance that you really have to consider based on your use case and based on, you know, what the consequences are actually going to be. Okay, and so let's talk about, you know, now that we kind of have an understanding of risk and safety in general, let's talk about, you know, how we can actually design our engineering products with safety in mind. Okay? And so, you know, this is not really a how-to, but maybe some guidelines for how to design safe engineering products. Okay. Okay. And so the first guideline that we'll talk about is to simply, you know, you have to comply with, you know, any safety laws. Okay. And so this is, you know, going to be first and foremost for, you know, any kind of engineering design is that you have to kind of follow all the safety laws that are associated with it. Okay. And a lot of times you're not even going to be able to launch your product if you don't comply with these laws. Okay. And so usually, you know, these laws are not too strict. You know, so this is usually not too difficult as long as you kind of follow good practice. But you know, it's always good to keep in mind. Okay. Okay. And so the second guideline is to not only comply with the laws, but also comply with, you know, standard accepted engineering practice. Okay. And so we saw this with the Pinto, right? So the Pinto, you know, they were able to comply with all of the laws, but because they didn't kind of comply with safe engineering practices, you know, their car ended up, you know, doing a lot of bad stuff. Okay. And so usually these accepted engineering practices, they're a bit more stringent than the laws, mostly because these engineering practices can be, you know, rewritten at a much faster speed than laws can. And so typically, you know, the process of changing the law is usually a very long and you know, laborious process. So it takes you know, quite a bit of time. But you know, usually to change like an accepted engineering practice, you know, usually all that has to be done is, you know, a group of engineers, you know, that work at a professional society, they have to meet, you know, and they have to kind of just decide that they want to change one of the practices. Okay? And so, you know, one of the most important responsibilities that you'll have as an engineer is to not only be up to date with all the applicable laws that's going to apply to your project, but also to stay up to date on, you know, all the relevant professional societies and, you know, and any kind of best practices that they suggest. You know, especially if you start to work in management at your engineering companies, you know, you want to make sure that all of your employees are, you know, up to date on these standards, so you kind of produce the safest products as possible. Okay, and so the third guideline is to explore potentially safer designs. Okay. Okay. Right. And so, you know, just because something, you know, just because one of your designs hasn't hurt anyone yet, doesn't mean it can't be improved, right? And so a lot of technology, there's always kind of rooms for design improvements, okay? And so, you know, it's always good practice to every now and then say, you know, I have this engineering product here, but also, you know, you want to think about, you know, can this be improved in any way, okay? And this is actually a constant thing too, because, you know, outside of your own field or outside of your own project, you know, new technology and new methods and new tools are being developed basically all the time, okay? And so, you know, a lot of times it might be possible that if someone makes, you know, a breakthrough in like battery design, then you can use that breakthrough to improve your own product, okay? And so it's always, you know, it's always going to be useful to kind of stay up to date with what other people are working on, maybe, you know, not in your specific field, but maybe in some of the related fields, such that, you know, can I use some innovation in that field in order to make my product, you know, safer and better, okay? And so keeping your mind open for impossible design improvements, is always going to be is always going to be better. Okay. And number 4, the fourth guideline is to predict any potential misuses for your product. Okay. And so remember, like what we talked about at the beginning today, is that you have to remember that your consumers, most of them are not going to be engineers. Okay. And so because of that, they might not understand, the best ways to use, a certain product. Okay. And so you kind of have to prepare for this. So you have to kind of prepare that people are either going to do it the wrong way, or do something deliberate that puts their life and safety at risk when using your product. Okay? Now, most of the times you can be pretty reasonable, so you can assume that you're not going to be designing pencils for John Wick, and they're not going to go around stabbing people with it. But you have to be kind of reasonable, right? And so I think there's some people here who are in computer science and in computer engineering. I think you guys kind of understand kind of what I'm talking about here. Where if you write a program or you write a website for someone, you have to assume that they're going to click in the wrong thing all the time. So if you make these assumptions, then it kind of helps you kind of guide your design to make sure that you kind of guide people to kind of the correct way to use certain things. Okay. And so even if things aren't directly your fault, and you might think that someone used your product in a totally unreasonable way, but people could still sue you over those things. So it's important to kind of keep these in mind and to try to design your product where it's almost foolproof. Okay. The risk of AI. Oh yes, yeah, AI. AI is that's definitely a pretty hot topic, and a lot of potential misuse for that. Okay, any questions on this? Okay. All right, and so the last thing I want to do today is I want to do one more activity. Okay. And so I'm going to put you guys in the same groups that you just were in. Okay. And what I'm going to do is I'm going to give you a product. Okay. Okay. And then with that product, I want you guys to answer these 4 questions. Okay. And so the first question I want you to answer is to characterize any risk that's involved with using this product. Okay. And so, you can characterize them as short-term, long-term, but even more just simply, I want you to kind of to describe, what are the bad things that can happen to you if you use this product? Okay. Or question, but if they use it incorrectly, that's not on you, correct? Since most things with an instruction guide list the warnings, hazards, etc. Yeah, that's true. So it's, but when you're designing these products, you guys are going to be responsible for writing those instruction guides with the warnings and the hazards and stuff. So you want to make sure that you're really clear and with those things too. Yeah. Right. So number 2. I want you guys to look up any applicable laws and any kind of accepted engineering practice that promotes safe design. Okay. And so that's number 2. Okay. Yes. Every field has their standards. So I want you guys to look that up for the product that I give you. Okay. And so you're going to have to use the internet for this. And so definitely make use of your laptop that you have right here. Okay. And so number 3, I want you guys to brainstorm any potential ways that the design can be improved from a safety point of view. Okay. And number 4, I want you guys to brainstorm, what are some ways that the product can be misused? Okay. And in particular, for some of these products, you might be able to look up, any famous incidents of misuse, that usually they end up as a court case. Okay. Okay. And so I want you guys to write down these 4 questions, and then I'm going to break you guys up into your groups in in about a minute. Okay. And so for some of these questions, you're going to have to use the internet and use Google to help you out to answer some of these questions. Okay. And so normally what I like to do with this is I like to break you guys up and then bring it back to share. But I think because we only have 15 more minutes, I'm just going to have you guys just discuss in your groups, okay? Because it is kind of a fair amount to research. Okay. Okay. And so I'll give you guys kind of 1 more minute to write this down, and then I'll break you guys up into groups, and then I'm going to visit each of your rooms and basically tell you what product you guys are going to be researching. Okay. Okay, so I'm going to go ahead and open up the rooms again, and I'll go ahead and visit each of your rooms to tell you where where you're going to be. All right, so you guys are group 1. So I know some of the people are still joining, but you guys are going to be responsible for motorcycles. And so I want you guys to answer the 4 questions that I posted before for motorcycles. Okay.
Cool. Thanks.
Yep.
Different group. We're back.
All right, group 2. So this is your same group that you had before, right? Because I didn't close the breakout room. Good. Okay, so the product you guys are going to be responsible for are RVs. So those are recreational vehicles. So I want you guys to answer the 4 questions based around RVs. Okay.
Okay.
Okay. All right, group 3. How are you guys doing?
Pretty good. Doing good.
Okay, so for you guys, the product that I want you to go over is helicopters. And so I want you to answer the 4 questions that I posted before for helicopters. Okay.
Untitled
Chapter.
All right, so this is group 4. How you guys doing?
Okay.
Good. Okay, so the product that I want you guys to research for these 4 questions is going to be suspension bridges. Okay. And so I want you to look up, the laws and all the risks involved with suspension bridges. Okay. All right, group 5. How are you guys doing?
Doing good.
Good. Okay. So the product that I want you guys to answer the 4 questions for is Internet Explorer. And so if you take Internet Explorer, I want you guys to characterize the risks and to kind of research any laws that are applicable to that. Okay.
All right, cool.
Okay. All right, group 6. How are you guys doing?
Good.
Good.
Okay.
How are you?
Good, good. So the product that I want you guys to research is gas pumps. And so I want you guys to answer the 4 questions that I had before for gas pumps, okay? Right. I'm gonna move on to the next room.
Hold on.
Hang on, let me, so you guys' product is gonna be power strips, but group 6 wanted to ask a question real quick. Okay. I clicked out once or something. You guys have a
That's okay.
question?
I was just gonna ask, is there a specific way I need to Google how, like, for laws and regulations?
You can just Google, laws involving gas pumps, and then that should kind of help.
Okay, cool.
Yep.
All right, thank you.
Mm-hmm. Sorry about that, guys. So your guys' product that I want you guys to research for the 4 questions are power strips, okay? Or surge protectors. So any kind of, anything that involves electrical plugs, okay? All right, sound good? Okay.
Yep.
All right, group 8. Sorry, I'm making my way around to everyone. So the product that I want you guys to research are microwaves, okay? And so I want you guys to answer the 4 questions for microwaves, okay?
Cool.
Good.
All right.
Hello.
Group 9. Hey, how you guys doing?
We are good.
Good. Yeah. Sorry for the wait. I have to work my way around to everyone. Okay. So the product that you guys are going to be responsible for the 4 questions are going to be GPS. Okay. And so I want you guys to research. What are the laws involving GPS? What are the risks? And any kinds of potential misuse for that. So just answer those 4 questions for GPS. Okay.
All right.
All right.
All right. Group 10. You guys are the last one. Sorry, it took me a while. How are you guys doing?
I'm pretty good.
Doing good.
Good. Okay. So your guys' product that I want you guys to look up is a clothes iron. So an iron that you use to iron your clothes. And so those 4 questions that I posted, I want you guys to answer them for clothes iron. So what are the risks that are involved? What are some laws and stuff like that, and how can they be misused? So go ahead and look those stuff up, and then if you have any questions, you can go ahead and summon me back anytime. Okay.
Sure. Thank you.
Mm-hmm.
Thank you.
Everybody, welcome back. All right, just wait for everybody to come back here. Okay, so I think everybody is rejoining now, right? All right, so hopefully everybody had good discussions. So I usually I like to kind of share what everyone kind of discussed in here. Oh yeah. Sorry we had to end it here, but it's 2:15, and so I don't want to keep anyone for over the lecture time. So and so we're gonna call it for today. But definitely, if you had some good conversation going on, definitely feel free to continue them outside the class. But that's all we got time for today. So thank you everyone for tuning in as usual. So remember, there's no class tomorrow. It's not like we meet tomorrow, but maybe some of your other faculty might need to be reminded of that. And so I'll see everyone on Thursday. Okay.
See ya.
Thanks, guys.
Professor?
Yep.
For the final project, that signature you want to do today, do we just email you it, or how does that work?
Yeah, just have one person in your group just email it to me.
Sounds good.
Yep.
Why did you want all of us to sign it? Like physically sign it, or just write our name?
Just put your name. I mean, it's normally when we're in person, everyone can sign it just to make sure that everyone's kind of on board with it. But I know PDFs have some way to basically apply a signature there. But if you just put your name, if everyone puts their name down, then I'm going to assume that everyone has agreed to it, and that's all that I really care about that.
Okay, thank you.
If you want, you can drive to each other's houses and sign it, but yeah, you don't have to. Oh wow, you're in NorCal. Yeah, that might be a journey. Yeah, just virtual signatures is okay.
Have a good day, Professor.
Thanks, you too. Eduardo, did you have any more questions?
Oh no, sorry, I just forgot to log out.
Okay. Yeah, I'll see you
All right,
Thursday.
thank you.